what we did in part 1 and part 2, and that will give you a refresh of what has happened before. If anybody has actually missed it, then we can that helps them as well. So I also felt like I just created this website just to make sure I kind of share more than what we are covering in this sessions. So whenever if you are free, please go visit that. With that aside, this is the agenda for today. In fact, this is what people have been looking for, which is basically about GitHub. Now, even though I'm trying to focus GitHub in this presentation, again, I'll make sure I'll present it in a way that will fit well with what we have seen before. So earlier, first session and second session, part 1 and part 2, we really looked at Git primarily from a local setup. So we didn't need an internet connection. We didn't interact anything with GitHub. It's just that we created a project within our system, and then we try to use Git, and we try to master a bunch of concepts within Git. But this part 3, basically requires internet connection, because we need a way to download stuff from GitHub or upload stuff to GitHub. So that's one striking difference. In fact, the commands that you're seeing, the topics that I'm going to cover today, about GitHub, of course, and then remote, push, clone, fetch, pull, all of these commands, these are basically Git commands, and these commands require internet access. So just keep that in mind. Let me straight away jump into the recap section. So I just put together what we have covered in last. Basically, this is a consolidation of what we have seen in part 1 and part 2. And if you see here, this top section is about part 1, and the bottom one is about part 2. So I'll quickly go over these commands so that we don't want to waste more time going through them. So we did see what Git init is. Git init, just to summarize, it's basically to enable a project, to enable a set of programs that you keep writing in your lab and make that as your Git enabled project. We use Git init. So that's the first command that we saw in this series of Git talks. And then once you enable a project with Git using Git init, we very frequently type Git status. So Git status basically will give you the status of the repository, like what files are there, like what changes you have done, and things like that. So this is the most frequently used command to know the status of what files have changed, or any files got deleted, and things like that. Excuse me. And the general workflow, if you look at day-to-day workflow, when you create a Git enabled project, all you kind of do is basically you do git add, and then you git commit it. So it's just to recollect, it's sort of creating a transaction in a bank statement. So these are the two steps that we use. Let me open my pointer. So these are the two commands that we very often day to day we use those two steps to basically, eventually the idea is to record your changes so that at any given point in time you can inspect them by going back into the history using other commands like git log, git diff tool, and things like that. You can look at what changes are been happening in your code base. Now, like I said, git log is it's almost like you looking at your transaction statement in your bank. You're basically looking at each transaction in your bank statement, right? So this is also very frequently used command, and in order to inspect a specific commit itself, like what changes have went into that commit, we basically use git diff tool. Okay, we use git diff tool so that what it does is you give git diff tool head tilde 1 dot head. So when I do that, what I'm asking it is, show me the changes that are happened in my last commit. Remember, head tilde 1 dot head means like we are only asking for one commit. Okay, that's the range syntax that we talked about. Now, so these set of commands, these 6 commands, is something like you have to master to work in your day-to-day projects. if at all you are working in Git enabled projects. Now, these two commands, which are also part of part one, are mainly meant for undoing changes. So you accidentally created a commit and you forgot to add a file into it, right? So you use git reset. What it does is it basically unpacks the commit and leave the changes there. So when you type git status, they will be shown as a red color. Now you can use git checkout to clear those changes as well. So you want to discard those changes. So you accidentally added modified line 4, right? And you committed it by accident. Now what you do is you do git reset, and what it does is it will unpack the commit, but it unpacks it but doesn't discard those changes. So the changes will be still be there. If you type git status, they will still be visible. In order to get rid of the changes, you use git checkout. So if you visit and watch part one presentation, we will know more details about how these two commands work. Again, very rarely we will be using these commands during your day-to-day workflow, but it is good to know that there are these commands to undo any mistakes that you have made by ignorance. And then coming to part two, so again, like I said, none of these commands require internet connection. So we picked a project and we enabled Git, and then we started leveraging Git concepts to track the changes. That's all we have been doing in this part one. Okay. Now, part two is where we kind of made it slightly complicated, in the sense that we wanted to have multiple streams of work. So like I said, you are releasing a product for February, and you want to keep track of changes that are happening in February release. That's where we come across this concept called a branch. At a high level, just to recap, branch is where your commits will be. So all the commits will be they cannot live, they have to be on a branch. So you can have multiple branches, but the most fundamental idea that you have to keep in mind is, as you switch branches, the underlying project content will be changed according to the commits that are there on the branches. So let me repeat that again. So the most important idea is, the reason why we have branches is, when we switch branches, you can basically switch from one branch to another branch. When you do that, essentially what we are doing is you're changing the underlying project source files. So in branch one, let's say in main branch or master branch, whatever it could be, you made some changes. You added a file, or you deleted a line, or you added a new line, and things like that. You committed it, right? That's a piece of work happening in main branch. Now, if you try to switch to branch 2, those changes will not be there. So you will have a fresh copy of your working space, your project. So any changes you do in this second branch will only be applicable to that second branch. Again, please watch the part 2 video to really get to understand the nuances of how this branches and things like that work. We create a branch using git branch, and one important point here is you have to specify an existing branch or existing commit from which you want to create your new branch. It's like you have like 3 or 4 commits. The way you create a new branch is basically by referring to either the last commit or to one of the previous commits. What that means is essentially you're creating a new branch off of that. So if you switch to this new branch, what happens is the changes will be reflecting from that commit. So that whatever changes are there in that commit, from that commit, your changes will be reflected on your project or on your hard disk. So that's about branching, and we switch branches using checkout command. So you give git checkout, that whatever branch name you have, you can use that. And by the way, when you do git branch, it will list out all the branches that are there in your system on the project. And like I said, you switch branches using checkout. Again, this is a shortcut way of creating a branch as well as checking out to that branch, meaning switching to that branch. So Yeah, so I'll keep it here. Let's not go too deep because we are on a time crunch. So that's about related to branches. And then we come across a situation where it's not that being able to create multiple branches is not the only use case. Eventually you might have to even reconcile those work that you're doing independently into a common branch. So you, just for an experimentation sake, you could have created an experiment branch named experiment, right? And then you did all your experiments there, and the code is matured enough that you felt it's a good time to merge that code into your master branch so that everybody can benefit out of it. So there we come across this concept of merging branches. So that's where we use merge command. So git merge, and then to which branch you want to merge. Okay, so this is how the command look like. And one side effect of one advantage and disadvantage of merge command is, advantage is basically it creates a merge commit when two branches have, like, let's say first branch has two commits and second branch has one commit. When you merge them, what happens is you will get a it not only merges them, but it also creates a merge commit. It's sort of an empty commit, but there is a commit there. There is a special commit called merge commit. Now, it's both an advantage as well as disadvantage. Advantage in the sense that you can basically undo it at any given point in time. So let's say you don't want to merge them, for you accidentally merged or merged or whatever, you can undo that, because that itself is a commit. You can use your reset command to unpack it, and at which point the branches will be on their own. Now, the that's about the advantage, but the disadvantage is your history becomes very complicated to look at. So when I, as a developer, when I type git log, I want my changes to be in a proper sequential format. Like, I want to know, like, this is the last commit and this is my previous commit. So it has to be very sequential. It should not be like because you're curating that merge commit. When I do git log, what happens is your merge commit will be shown in the top, and then immediately a commit from this branch can appear, or a commit from the second branch can appear. There is no proper ordering. So that's also slightly disadvantageous, like when you want to inspect your log. At, to address that, we generally uh, 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 I mean, I shouldn't say we avoid merge. We do use merge often, but there is another way to get the changes from your experimental branch to your master branch. That is by using rebase. So again, I don't want to go to the details here, but rebase essentially does the same thing as merge, but without the merge commit. So I really encourage you to basically go watch the part 2 video to really understand the nitty-gritty details of these commands. But like I said, Git is a tool where it requires, it's not like, I promise you, even if you watch these 3 sessions like 10-20 times, unless you do it, unless you practice it, uh, things will become very confusing. So watch the videos and also make sure you practice them with your lab programs. They are the easiest way to get a hands-on experience with these commands. Now, uh, so these commands, part 1 and part 2, as I called out, none of these commands really require any internet connection, because everything is happening within your local setup. Basically, it's a local project and it's a local setup. Okay, so I'll stop here and let me know if you have any questions, so that let's clear up any doubts or any questions we have, so that I'll introduce you guys to the part 3 section. Looks like nobody have any questions. So if you have any questions, just stop me in the middle of the presentation. Okay. Now, up until now, like I said multiple times, we only saw local way of using Git. We used Git commands and we only worked with local projects. Now just keep that aside completely. And what I'm going to show right now is just without even thinking about what we learned up until now, just keep yourself like you have no idea about Git, and let me first walk you through GitHub, and let's try to see whether we will be able to make sense out of what GitHub is, okay, with the knowledge that we have with Git. So here I'm going to open a project of mine, and I'm just going to walk you through the interface of GitHub. Okay, so so every time I don't have to explain this, but basically you have to have a GitHub account which you can easily register. It's for free, and all you basically do is create projects. So I'll talk about how to create projects and things like that. But before even going there, I want to really show you what a project even look like on GitHub. So now, if you see here, this project is exactly the way it looks like what I have in my local. Okay, if you see here, they look exactly the same. Okay, so GitHub, you can think of it as a place to put your source code, and it's not like any place to put your source code, but it basically gives you an interface to experience all the Git tools. So what you're seeing here is here you see one branch. Apparently in this project I only have one branch. That's why you're seeing that main branch. Okay, so it's almost like you did git branch on your local machine. So if I just do here, let me go over here. So if I do git branch, the way I'm seeing one branch main here, that's exactly what I'm seeing here. Okay, again, let's not confuse how this code landed here. I'm going to talk about that later, but what I'm trying to explain here is for any Git project that you see on GitHub, these are the things that will be there. Like you will see list of branches, you will see the folder structure that you have, and you will see the commits. So if I basically click this commits, I can see what all commits I have made. Apparently I'm lazy enough, so I only keep pushing my changes with fix-ups as my commit message. Ideally this should be much more meaningful. Okay, so this can you recognize what this look like? So when I clicked the commits thing in the home page, what I'm getting here is basically my git log, isn't it? So if I do git log, even though the format might look slightly different, this is exactly the same thing. You see this? So the point that I'm trying to make here is GitHub is basically a fancy web application to visualize, or to, it's sort of a front end for your Git workflow. So whatever you are doing on your command prompt is exactly what is there on your GitHub. There's nothing different. So the way I can use git diff tool to look at each commit, what happened within a commit, I can come here and I can click this and basically, or maybe click this, and then I can see what changes have happened here. Okay, it's like you're invoking git diff tool to see the changes that are happened in this specific commit. So the reason why I'm explaining it this way is GitHub is nothing complicated or nothing fancy. It's just a way in which it's an easy way for you to access your resource. Essentially, you go to any other computer and then you can just still have access to your GitHub, your Git project. So somebody asked me in the first part, like, what happens if your hard disk, or what happens your somebody steal your laptop, or something happens to your repository that is there in your hard disk. Yes, if such a situation happens, then we lose our source code. So that's why we have GitHub. With GitHub basically is a centralized location where you upload your source code. Once you upload it, it's there forever, so you can access it from anywhere, and things like that. Now Not much in GitHub is really needed at this stage. I'll talk about how we create a GitHub project. In fact, a single GitHub account can have like multiple projects. That's the idea, right? So um, this again, let's not go over any of these because these things are really needed for a real world projects, like projects which require a lot of communication between the team members and things like that. So let's not go to any of this. All I want you to understand about GitHub is basically to master just try and understand that it is nothing more than what you have been doing on the command line. Okay, if time permits, I'll also go over a bunch of uh, uh, other details within GitHub. So for now, let's keep it here. Let me switch back to the slides. And so now we basically saw two things. One, we learned how to use Git in the command prompt, and the other, we saw what GitHub offers. GitHub offers a space for you to put your projects, and it also not only offers a space, but it also offers a interface, the UI, to for us to quickly look at our changes and quickly look at our logs and things like that. In fact, you can create new branches here. Okay, but the point here is whatever you have on your local can be exactly duplicated in your GitHub. So if you say, if you have, let's say on your local machine, let's say I have like 3 branches, I have created 3 branches. When you upload your source code, those 3 branches will be replicated on your GitHub. So let me also show you another project which has like bunch of branches, so that will help you understand what I'm talking here. So if you look at here, this is a glibc project which happens to have like a bunch of branches that people are working on. Okay, so this is how many branches that are there on this GitHub. Okay, so now we come across something called as cloning. I'll talk about it a little later, but the point is when I do that, essentially I'll get all these branches, all this source code into my local machine. I'll talk about it when we come to that slide. But before that, I want you to introduce a concept called remote. What we mean by remote. Now, it doesn't help you how no matter how efficient you are at using Git, uh, if it is constrained to your local machine, right? Like I said, it has its own drawbacks. Once your hard disk is gone, your entire project is gone, which means at some point in time you have to upload your code base to some remote location. Naively, beginners, what they generally tend to do is like they copy that entire folder and email themselves, or put it in their OneDrive account, or put it in their Google Drive account, something like that. We all kind of did these kind of scenarios. Like that's the easiest way to do it, but that's not the ideal way to do it. Instead, what we generally do is, since we have a local copy of our Git project, we create a project in GitHub and then we upload it. Okay, now in order to do that, we just need to understand what the concept of remote is. Now, remote is basically, like I said, it's a place for you to upload your source code. The beauty about Git is like you don't have to upload to one GitHub account. Instead, you can upload your single project into multiple accounts. It's almost like you have a photo and then you're trying to share. You can share it to like different applications, right? So something like this, even though it's not a right metaphor, but think you can think of it as that way. So idea is you can have like n number of remotes. Remotes are basically places where you can upload your source code. Okay, now generally every project will have usually have only one remote. Having more than one remote is not that common, but something to keep in mind is every Git project can have like multiple remotes, multiple places where you can push. Okay, so the way we know what is the remote, what is the default remote that is configured is we use this git remote -v. When you type that, what it tells us is there are two parts here: the name of the remote. Usually in Git's literature, the way default branch name is master or main, the default remote is always called origin. Just keep that in mind. So it's basically a shortcut given by Git to refer to this this particular remote location. Does it make sense? Don't worry too much about why we have two entries here. That's not very important here. But the point that we need to remember is remote is basically a location somewhere outside on the internet where you can upload your source code. Now, just to repeat myself, Git by default gives the default remote, the one and only remote, as the name origin. So anybody, when they refer to origin, what they're referring to is they're basically referring to that remote location where this code exists. In all purposes, for our use case, basically GitHub. You can think of remote as GitHub to keep it simple. Okay, like I said, origin is the default name given to the remote. Now, I had to bring this topic in the middle of nowhere. I had to bring this topic. Just bear with me. It all makes sense once we move to the next slides. Now, do we really need to go here? Okay, let's go. So basically, one additional step that you have to perform in order to leverage your GitHub account is when you're uploading your source code, it doesn't ask you for your username or password, right? So it's not like you logging into your email. So usually, in order to access your Gmail or whatever, you use your username and password, right? But generally, GitHub or any other remote locations for Git, we don't use our username and password. Instead, what we do is we configure our SSH public key into our GitHub account. These terminology may sound fancy, but it's very simple. So go to your GitHub account's settings. Okay, this is like a one-time thing that you have to do. It's not needed for every project. It's only a one-time thing that you do for a given machine. So right now on this machine, let's say I want to upload my source code to my GitHub account. All I have to do just once is upload my public key into the GitHub account. By doing so, GitHub will trust me. Whenever I try to upload my source code, GitHub will recognize that, yes, Vineel is the one who is actually uploading the source code. So I will let him in, let him upload the source code because his public key is with me. Okay, that's the idea. So you go to your SSH and GPG keys. So on Windows, even on Linux, basically all you have to do is you do SSH keygen. What this does is it basically generates two keys. One is private key and one is public key. So it saves in your user account /.ssh, and then this is a private key. It will not have an extension. Whereas file which has .pub extension is called a public key. So I don't want to go into the details of how public key, private key, all that works. We don't need to know, first of all. All you have to do is pick your public key file, open it in your Notepad or VS Code or whatever, and then copy its content. And then you just have to come here, click new SSH key, okay? And then you simply paste it. You can give a recognizable title. So once you give that, so here if you see, I have two machines with me. One name Vineel ADL-S, and there is one HP Omen 16. So I have two machines which I tend to use. So for those two machines, I uploaded the public keys from both the machines to my GitHub account. So what that helps me is I can at any given point in time upload my source code from both of my machines. Okay, so This is the setup that is required for you to upload source code into your GitHub account. Now, this is all you need to know. Nothing more is required. Okay, let's keep it here. Now, with the setup and what GitHub is and what local repository is, now let's see how, since we have the local copy of a repository, so in fact I can basically do right now. So let me see. So I have a local repository. We have been working since part 1 of this. So I have a bunch of commits, and I have, if I see branches, I have 2 branches here. Okay. Now what I'm going to do right now is I'll create a repository. Okay. So you go here to the right, and then you click this new repository. Okay. Now I can name my repository anything I want, but the general practice is usually we tend to name whatever is your local project is. Okay. Already exists. Okay, let me delete that project. Looks like I already have that, so let me quickly delete it. Just give me a second. So by the way, once you're done with your project, you can basically delete it by going into its settings and then go all the way down. At the end of that, you will see delete this repository. Want to delete it? Yes. Yes. Okay, just a second. I need to use my authenticator. So I have my 2-factor authentication configured. That's why it is asking me for. Okay. So this is how you delete an existing project, if at all you want to delete it. Okay. Now let's come back. We want to create a dummy blank project. So that's what I'm trying to do. I click this plus new repository, and then I'm pasting my the project name. Okay. Now it is available, and usually we have 2 options to either make this project public, which means you can share this URL to anybody and anybody can access it. They can basically look at your source code. Now, generally, if you're working on a super secret project, usually that's what companies does. So what they do is they don't create public repositories on GitHub. Instead, they create private repositories, which means you cannot access it only when you log in and things like that, you will be able to access it. So for now, keep it public. And then all you have to do is just click create repository. What we have right now is a dummy template or a dummy project which has no code in it, no branches in it, nothing. So it has nothing related to our source code. Okay, that's the reason why GitHub gives you 3 options. Okay, we have first option, we have second option, we have third option. Either you can manually import your source code, which is not advisable. So let's not go there. Reason why it's not advisable is because it's almost like you zipping your source code and uploading it, which will not contain any branch information. So it's this. Let's not even use this third option. Okay. The preferred approach is using the second option, which is why I have to explain you what remote is. Because if you look at the first, I don't know whether you guys are able to see this, but let me zoom it. So the second option here is, it is giving us instructions which you have to run in your local in order for your local source code to be uploaded to your GitHub account. So to do that, the first step is we need to run this command. So I go here. Let me see if I have remotes already. I don't have any remotes. Okay. So just carefully observe this command. It's not that complicated. So what I'm trying to do here is basically I'm trying to add a new remote. That's what it means. And then I want to name that remote as origin. It's a shortcut, like I said. and the actual remote location itself. Okay, remote project location. This is what we do. When I do this, um, just give me a second. I'll back up this project just in case if we need to redo this, we will have a copy. Okay, so hope you guys understood it. So what I'm doing in the first command is basically now I'm telling my local repository that bookmark this remote location so that whenever subsequently when I try to push to origin, you figure out and upload to the right location. uh, just upload the source code to this particular location. Okay, that's what it means. Now you can name your remote as anything you want, but like I said, the tradition is to call the one and only default remote as origin. So I'll stick to it. Okay, now if I type my previous command git -v, now it will show me that origin is the shortcut name, and this is the actual location where that remote is. Okay, now the reason why I'm saying so much about this origin is we keep using this name very frequently, so just stick to it. Now uh, you really don't have to do this, because you really don't have to do these two commands. All we need to do is this: it will set the thing, and then I'll give you a command which I am going to explain later to upload it. So let's look at this. What I have been carefully using the word upload up until this point, just so that you won't get confused. So but the real technical word to use is push. It's not upload. Upload is not used anywhere in git, but instead what we use is push. Push is basically you're saying git that go upload my source code to whatever remote that I'm specifying here. So if you look at the command, all I'm doing is upload my code base to this remote, which happens to be GitHub. And this is the funny part. So head means where am I? So let's say I'm in feature branch. So let me do this. Something like that. So when I say head, remember when you do git branch, if it is green color, it means that's the branch you are on currently, right? So head refers to your current branch. In this case, it happens to be feature. Now, when you push code to GitHub, you only push one branch at a time. You do not push like all the branches. Okay, just keep that in mind. You only push one branch. That's why we have to specify which branch you want to push. Okay, so I'm by using head here, I'm specifying that my feature branch is what I want to push. Now, this after colon, we generally keep the name same as what we have here, feature. What that means is push my local feature branch into GitHub and also name the branch as feature there. There also let me call that branch feature. If you're if you want to more customize it, you can in fact push your source code with a different name. Like right now what I'm doing is I'm pushing my feature branch as feature underscore 123 in my GitHub, but that's not what we generally do. We generally do this. So you basically keep your whatever is your local branch name also the same with your remote branch name. So usually we tend to keep it same. Git is already very confusing, so we don't want to confuse ourselves, so we try to keep as simple as possible. Now this is the command that we use. So when I do this, oops, apparently I didn't have this configured or what. Just give me a second. I think I have modified my GitHub. Let me see if it works with my. Why is this asking me right now? It shouldn't ask. Anyway, let's see. Anyway, I'll figure that out. But usually when you upload your SSH key, it shouldn't ask you anything. Like once you type your git push origin head colon the feature name or the branch name, it will basically upload it. Now, once you see this text, new branch head arrow feature, what that means is essentially Git has uploaded your source code, uploaded your current branch to GitHub. And if you go to your GitHub account, and if you try to refresh your page, you would see your source code uploaded here. So my hello world project, which is there in my local machine, has got 2 files, and that's the branch which was uploaded to the GitHub. So this is how we generally push code to remote repository. Okay, now I'll keep it here, and then let's see. I think I have already covered this. So what is happening here pictorially is like I have a local code base which has 2 branches, one master and one feature branch created out of C2. And then when I do git push origin head colon whatever, now in the remote repository, which means GitHub, that branch, only the feature branch, because I'm only pushing feature here, that feature branch gets created in my GitHub. That's exactly what we saw by opening GitHub in the browser. Okay, so this is what we mean by push. Now just keep this in mind. We might revisit this again, but this is this many documents and many places people say git push. Also, they don't even specify this. Git push also works. You don't have to explicitly specify this, but I got habituated to use this command this way because it's more explicit. It's more explicit in the sense that it tells you exactly where you are pushing and how you are pushing and which branch you want to push. Okay, but if you come across any documentation which does not give this, it also means the same. It's basically pushing to the default remote and with the default whatever is your current branch. So both are same. I tend to be explicit with this just because I have this been using this for quite some time. So yeah. Now what we saw up until now is we successfully uploaded a local copy of your source code to GitHub. Okay, let's do the other way around. You found a project in GitHub, and now how do you get it to your local machine, right? So that's where we use clone. So git clone is basically downloading. So it's like you downloading a resource from the internet. Now the uh, so usually most of the times git clone is a one time only command because you download your project once, and then you don't have to run this command every time. Just use it once and it will get the source code. Now let's look at the scenario. Okay, this is how it is on GitHub. So GitHub has got 2 branches, one master and one feature. The reason I am prefixing it as origin is because, okay, so when you do git clone and give the URL, so let me show you the place where we have it. Let's say I want to clone this. Okay, this green button is what you have to click. So let's say you did this and go to SSH. Always go to SSH because that's the best way to download or upload source code. Okay, let me go to some other random directory. Okay, let me go back. Let me create a folder purpose. So all I do is, this is what I do. So I just copied this URL and then I pasted it. So when I do this and hit enter, it basically clone. Actually downloading the entire content of this GitHub repository. This is what we mean by cloning. Now, unlike your push, when you clone something, you get all the branches that are there on the on your GitHub. So whatever is there, let's say if I clone some other project, apparently this has only one branch, so I don't have other examples to show you. So let me let me see this. Maybe this project might have like multiple branches. Oops, even this has only one branch. So let's take this. I'm sure this will have multiple branches. Yeah, like we saw. Okay. So if I try to clone this, same thing. You copy the SSH, go SSH and then copy it, and then you do. Again, when you clone, it will create a directory. So within this is where our code will be kept. So let me do this. I don't know how long it will take, but let's see. So this is basically, it is downloading now. So the point here is when you clone a repository, you get all the branches, which means all the work that has gone into that project into your local machine. So once this is done, I'm going to type git branch and you can see exactly how many branches you got. Okay. Now let it download. And I want to emphasize one very important fact that people tend to get confused very frequently, which is when you clone a project, the branches that you are getting from that remote repository, okay, in this case GitHub, are labeled as origin slash. Okay, even though on the remote, let's look at this example. It makes a lot more sense. Now if I do git let me clear this. Let me go to glibc. I'll talk why I'm giving -r, but look at the output. So if I try to look at the branch names here, you don't see origin anywhere here. Okay. But if I do the same thing here, all those branches will be listed out with origin slash. But the reason for that is basically Git is telling you that all these branches came from this particular origin, meaning this GitHub account. Okay. So just whenever you see a branch name with origin slash, keep in your mind that that branch actually came from GitHub, more specifically from a remote location. It's not created by you. Okay. So there is this distinction, but I haven't talked about it up until now, because up until now what we have been creating in the past 2 sessions is basically creating local branches, basically branches which we created. Whereas now that we are bringing in code from remote location, now we will also have branches that came from remote location. So you have like 2 sets of branches. One, branches you created locally, and one set of branches which came from the GitHub. So the branches that came from GitHub will be prefixed with origin. So they will always be in red color. That's how Git will highlight it. And in order to list out what branches I have, if I simply do git branch, I will only have one local branch, one master branch. But if I do git branch minus -r, it will show me what all remote branches did Git cloned when I used git clone command. So if I do this, it will show me all the branches that came. Apparently this project has got too many branches, but this is not how usually we will see projects. But I hope you understood what I mean by branches that are coming from remote and branches which are local to us. So when you clone a repository, we will only have one local branch, which is basically, again, Git by default creates a master branch out of the master, remote master. So when I do git branch, again, since this is a green color, it means that's my current branch, and also this is my local branch. Okay. To really see the remote branches, we use git branch -r. Now, another important command is git branch -vv, verbose logging. Okay. When I do this, it will tell me exactly from which remote branch did Git created this local branch. Okay, so it doesn't make much sense if Git would have just downloaded the source code and gave it to us. Instead, it goes one step further by not only downloading the source code or not only downloading all the branches, but it also creates as a local branch named master from the remote origin master. Does it make sense? So that we can immediately start working on it. So that's why, even though you haven't created any local branches by yourself, when you clone a repository, this master branch will be always created. And in order to know from where this master branch is created, which 99, I mean, almost all the time it gets created from origin master, but you can see this with the help of git branch minus VV. Okay, so um, um, so this is what we have right now. We cloned that Git glibc repository, and we have got all the remote branches with us. Okay, we only have one local branch. Apparently, it is created off of C2 because as we see this output, the master is created from origin master. It was not created from feature or anything like that. So this is the default case. So we have a feature branch here. So if I clone it, and then obviously the next step for me is to basically either I can create a new branch myself if I want to. In this case, what I'm doing is I'm creating an experimental branch. Apparently I don't need to create it because Git already created a master branch for me. But I'm just showing you guys how you can create a new local branch off of your origin/master. So if you observe this command carefully, git checkout -b, the name of your local branch, and then you have to specify origin/master because that's the source of truth. That's from that branch you're trying to create a local branch. Okay, but the most important point that people get confused so often is when I type this command, I'm not reaching to GitHub. Hope that is clear. When I cloned my GitHub account, GitHub project, I already got all the branches from GitHub, and it prefixed those branches with origin. So every time I refer origin /, don't think that I'm actually going to some internet or going to GitHub and then downloading or anything like that. No. Like I said, checkout, branch, all of these are offline only commands. They don't require internet connection. So clone is the command which requires internet connection because it has to download the code base, and also push is the command which requires internet connection in order to upload the source code. Okay, so just keep that in mind. You give a local branch name, and then you have to specify from which branch you want to create. Usually what we do is we create it off of origin/master because I just downloaded a source code. I want to be on the top of the latest changes that happened in that source code, and I want to work on top of that. So this is the general workflow that we do. So the new experimental branch will be created from origin/master. Apparently, this picture is not very accurate because I not only created a branch, but also I happen to work 2 commits after that. So don't take it literally, but ideally this experimental tag should be here. Okay, this is basically I worked on 2 commits. So I think like I covered this. The way we see remote only branches, we use git branch -r, and then -vv is also very useful command. I very rarely use -a, which will basically list out both the things. It's not that helpful, but -vv is very useful because it will tell you exactly from which branch the current existing branch is created off of. Okay, so with this, and then now let's go back. Now, before even I explain what fetching is, let's discuss a scenario, right? So since this project is in GitHub, right? So let's say you're working in a company, right? Companies will have their own GitHub accounts. So there are multiple developers working on a single project. Now, as a new joinee, what you did is you maybe your mentor will give you the location of the GitHub project location and things like that, and you use your knowledge of Git to clone that repository. So you cloned it to your local machine, your dev machine. Now, since it's a company environment, other developers, other teammates would also have cloned that repository, right? Everybody will have access to that repository. It's not your own personal account, it's a company account, right? So that project gets cloned by multiple people, which means along with you, all of your teammates would also be working on that project, right? So they would be working on it, they would be making changes to the project locally in their machines, right? That's what we do. And then eventually at some point in time, they will upload their changes to the remote repository, because that's the whole point of having a centralized GitHub account. Now the problem is, when they upload it, what they did is they basically uploaded new changes to GitHub, and because of that, what you have, the copy of the source code that you have now became stale, because there are more latest changes that are available on the GitHub. Okay, so if you try to upload, it may not work, because there are more latest changes that are there on the GitHub account. Now this is where fetch comes into picture. So fetch, what it does is, when you run that command, essentially it will get the updates that are happened after your clone. Does it make sense? So just to repeat quickly, so on day one, when you're joined, you cloned your repository. 10 days down the line, people, your teammates have also cloned, and they have also made some changes, and they also updated their changes, uploaded their changes they basically pushed their changes to GitHub. Now on 11th day, when you try to push your changes, it doesn't work, because you have been working on a stale copy of the code base. So the first step that you have to do is, first of all, you need to fetch any latest updates that are there on that repository, right? So you have a.java, and a.java could have been modified by your colleagues. Now you need to fetch it. Only then you have the latest copy of a.java, and then you can work on top of it, and then you can push it. Okay, let's keep it there. There are some nuances to it, but let's keep it there. So the git fetch command is used to get the updates, essentially. So I'll show you pictorially how that will look like, and then we'll get a sense out of it. Now this is what we have locally in your machine. As a new joinee, when you cloned for the first time, you have this setup. Okay, you have your origin master clone, and you for the 10 days you worked on it, and you created a couple of commits on your experimental branch. Again, this doesn't have an origin prefix, which means this is your local branch, whereas this is prefixed with origin, which means it's a remote branch. Now when I do git fetch, okay, what happens is, it's sort of clone but not clone. Clone is basically downloading the entire source code, but fetch is more of incremental updates. Okay, so when I do that, observe carefully to the left picture versus right picture. Okay, what is happening here is, git got the updated commands C3 and C4 from GitHub. Okay, what it did is, basically it updated all the remote branches to whatever is there on the GitHub. So your local branch has not been disturbed. It's still the way it is, F1, F2, and all it does is, git fetch, what it does is, it will update remote branches that you downloaded. So all your origin masters gets updated. It's almost like you're downloading your virus definitions every now and then, or maybe checking your updates, Windows updates or whatever, something like that. Okay, when you do git fetch, it only updates, the most important point is, it only updates the remote branches that are there in your machine. It sounds very complicated, because I kind of use both remote and local in the same sentence. So just to repeat, when you do git fetch, it downloads your updates to your remote branches that are there in your local machine. Hope it's not too confusing, but the idea is that. Again, fetch requires internet connection, because it has to go talk to GitHub and then get the updates. Now the beauty about git fetch is, it does not disturb any of your local branches at all. It doesn't touch any of your local branches. It doesn't try to put updated changes on top of your changes or anything like that. It only updates the remote branches. Okay, no matter what updates go into your remote branches, it doesn't make any difference to you, because you're still pointing to your C2 branch, C2 commit. Okay, so your code still remains the same. It doesn't get disturbed. Okay, I'm going to talk about what we will do after this, because all the intention of we doing git fetch is to make sure our changes are also on top of the latest changes, right? So just to repeat, when I do git fetch, I'm getting only updates to my remote branches cloned locally. Now, but that's not what I want. What I want is basically, I want my changes to be on top of like this, on top of whatever the latest that your colleagues have pushed, isn't it? So what we do instead is, we do something called as git pull hyphen rebase. uh, uh, let's see what will happen. So this is what we have. On the left, we have origin, we have feature branch. Again, this is local, it doesn't have origin in it. And you worked for the first 10 days, you worked on f1 f2 commits, and then you did git pull hyphen rebase. Now look at what happens to the right? So on the right, it not only got C3 and C4 from your basically whatever changes your colleagues have pushed to the remote, but also it rebased your local changes. F1, F2 got rebased underneath C4, which means you are now on top of your colleagues' latest changes. Okay. It sounds complicated. In fact, that's the reason why I had to explain what rebase is in part 2, so that you will understand what I mean by rebase. Rebase is essentially you reapplying or replaying your work f1 f2 on top of any latest changes. Okay, so this is the command that we use, git pull hyphen rebase, which does two things. One, it fetches, and it also does rebase. Does it make sense? So when it do git fetch, what happened? It got these two commits. And when it did rebase, what happened? This entire feature branch got moved underneath C4, which is effectively what we want. We want to work on top of the latest changes that your team has pushed. Does it make sense? So usually this is what we do every day in and day out. This is what we do: git pull hyphen rebase, git pull hyphen rebase. By doing so, you will your any existing work gets replayed on top of this thing. Again, if you have, let's say, two or three local branches, right? And git pull hyphen, just to keep in mind, git pull hyphen rebase only rebases your currently whichever local branch you are on. That branch gets rebased. Rest of the branches still remains on C2. Okay, like this. Just that's why I want to call that out. That's why I put this in brackets. Okay, so you right now I am in feature branch. Okay, right now I am in feature branch. I tried git pull hyphen rebase. What it did is it updated the remotes. I mean, it updated the remote branches, and then it rebased my work. Again, I'm repeating myself here. When I say updated remote branches, keep in mind always remote branches which were already cloned into my local, they get updated. It's not like I'm updating something in GitHub. Okay, just keep that in mind. So this is all I wanted to cover, just because this is the workflow that we do. So what we saw right now is we saw a couple of things. We saw how to clone, how to clone a repository, existing repository, how to see remote branches, and how to push any existing code. Okay, and by the way, once your changes are updated on top of the latest changes, remember, this is still a copy that is sitting in your local machine. This is not yet present in the GitHub. Does it make sense? So it's like you are updating your local feature branch copy. Okay. Now, ultimately, you have to do git push command that we saw earlier to push these changes to GitHub. Does it make sense? Now, subsequently, any of your teammates who want to work will repeat the same exercise. They do git pull hyphen rebase, at which point they get the F1 dash F2 dash changes onto their machine, and then they start working on top of it. Okay, so so we use git push to push the changes. We use git fetch to only update the remote branches that are cloned locally, and we ultimately use git pull hyphen rebase to get the latest changes. Okay, I'll stop here, and if I have time, I'll repeat it one more time, just so that I want to consolidate what we have learned and what we generally do in a day-to-day basis. That way it will help you more. But before going there, I'll stop it here, and let me know if you guys have any questions. Okay, so oh, no questions. Okay, yeah, that's fine. So just to repeat, like usually, since I'm working at a company, I don't have to clone a repository every day, because that happens when I joined the company or when I joined the team. Right, I only does it like once. So you clone a repository once, at which point you get all the code base, and then from then on, what you tend to do every day in and day out is git pull hyphen rebase, which will make sure you get the latest changes that are happened between the last time you cloned and now. And then all I do is make my changes. I use git add, git commit to create commits, and then you probably use git diff, git log to see what changes I have made. And then ultimately I do git push origin head colon whatever it is, the branch name, that will basically push my changes. And on day 2 I do the same thing, on day 3 I do the same thing. So you git pull hyphen rebase, you add, you commit, you push. It's just those 4 commands that you tend to repeat yourself. Okay, so again, this is nothing new here. So I'll basically stop it here, and then do I still have any time left, or are we on time? Still 10 o'clock, 8:30, 10. Yeah, I think I still have 10 more minutes. Okay. Let me see. So if you, so just to walk you through the GitHub interface even more is GitHub, the advantage of using GitHub is it's not only a boring Git interface, but it also has this social elements to it. Like if you want, you can follow someone, like let's say, I don't know where, but so if you follow anybody, basically whatever they update, you get that feed on your homepage basically. So if you follow somebody, whenever they make any changes to their repositories, you get a feed like this. And if you are interested, you can star the project. So I can star it, so I can have all the let me zoom out a bit. So where is that? I can go to my stars. So whatever projects I have basically bookmarked, I can see them essentially. So that's one good thing. And not only that, you can discover projects. Like you can use this search bar, not here. You can use this search bar to basically search any interesting projects. Let's say you are interested in C language, or you might be interested in some Python, right? You can I believe you can put lang colon or something like that, and then you can do Python, and then you can search the projects that are happening on Python. Or even more easier way is there is this explore button. I don't remember exactly where it is, but Yeah, you can click this explore and you can see what others have been working on, and you can create lists out of it, like something like that. It's basically writing code and managing code on steroids. uh, One thing is basically starring it, and then you can also watch. So basically you can let's say you're interested in some project. By putting a star, it's just bookmarking it. But if you click watch, what happens is you can get updates by if any changes happen on that repository. Okay. And and the other important thing I purposefully not included, so that to keep the session simple, is um, usually you cannot push to somebody else's repository. So I cannot push to this guy's repository. Okay. Instead, what I have to do is first I have to fork it. Fork means getting a copy of that project into your own personal GitHub account. It's like you fork a project. Let me show you. So if I fork it right now, so it will ask me, I'm just keeping the same name as his project, and then I'm creating a fork out of it. So when I do that, what happens is I got the project into my under my user account. So it clearly says that it forked from somebody else's location. It's very common. Now what I do is I clone this into my local repository, local machine, and then I keep working on it, and then I push it to my own account. Does it make sense? Now, once I feel that these changes should also be applicable to this guy's repository, that's when what I do is I open something called as a pull request. So again, these are very fancy, like a more in-depth uh, concepts. I don't want to complicate it, so I'm just giving you the names. If you are interested, just once you got accustomed to the basics that we have seen, you can Google them. But the point is, you create a pull request. It's like you're creating a request to this guy to pull your changes. That's what we mean by pull request. Okay. So all the pull requests that are there here, let's see if this guy's project has got any pull requests. Yeah. It doesn't have any pull requests. It seems all pull requests are closed, but this is how it will be. Like some other guy, he sent a pull request to this person to merge some changes, something like this. But yeah. And then GitHub not only provides you a place to host your source code, but it also helps you track any bugs. Like I said, it's not the boring Git commands or just Git commands, but it has these nice features on top of Git infrastructure. So you can have a bug management system. So you report a bug and you can start a discussion on it. Like you can label it and you can start discussions on it. I think this is for reporting issues, and recently they started this discussions section where you can generally float ideas, like you want to enhance something or you want to improve something. You can first start a thread. It's like a forum, essentially. So, most interesting discussions will be upvoted, and accordingly, people take actions on it. Now, the other thing as you can see, there are like tons of features and tons of elements that we can talk hours together. But just to keep it simple, I'm touching the most important topics here. Now, this section is very, very nice to look at. So basically, whenever you open a project, you have this languages section. It will heuristically figure out what this project, I mean, which language is this project written in. Apparently, this happens to be 88% of C code. So that's what, by looking at this section, you can quickly say, oh, this is a C based project. Okay. And I don't want to talk about the workflows and all. It's more complicated, but yeah, I'll just leave it here. That's about it. But I request you guys to keep asking questions may not be in the same session, but whenever you're stuck anywhere in Git, especially like I said many times, you cannot learn Git by reading a document or watching a video. It has to be done through practice. Only then you will be able to make sense out of these concepts. But yeah, feel free to ping me. I kind of tend to keep all the resources possible here. You can use Gmail, GitHub, or Edgroom, and all the resources, LinkedIn, whatever, basically. So I'm just trying to help you guys to master it, because without Git, there is no other. You basically don't walk into a company which doesn't use Git right now. Yeah, that's about it. So let me know. I'll pause for a minute or so, and then we can end the session. In fact, you can basically design projects as well. So you can come up with the timelines, like I want to implement this milestone for the next 15 days, something like that. This is a project management section as well. And you can also see insights like who is contributing, who are the contributors to this project. Like it will show you like which like there are like I think 4 people are contributing it. Like this guy made 218 commits, and during which time is he active? He was not active anymore. Something like this. There are a bunch of statistics on top of what we have, what we saw on Git. Okay, I'll stop it here, guys. Thank you so much for attending the session. And again, feel free to ask any questions and reach out to me if you have any if you're stuck anywhere. Thanks, guys.